I am Anil Kumar. Welcome to my series on prime factors. In this particular video, we will consider all the important concepts about prime factors and prime factorization, and we'll take up many applications as stated on the very first page here. Let's begin with examples and see what is a factor and how to get factors of a number. The very first example here is to understand numbers in standard form and as product of factors. So any number can be written as product of two or more numbers. So we will now consider this particular question, which says write factors and multiples of given numbers to complete the table. So 6, 7 and 10 are the numbers given to you. You need to write factors and multiples of 6. So as far as the factors are concerned, we could write 1 times 6 is 6, and we know 2 times 3 is also 6. So these become the factors of the number 6, since when you multiply them, you get the number 6. Now the multiples of 6 will be 6 times 1, 6 times 2, 6 times 3, 6 times, 18 it is, right? 6 times 3 is 18. Let me rewrite this. And so on. For 7, we have only two factors, 1 and 7 itself. And you will notice that if you have only two factors, then the number is called a prime number. And this is a prime number. The multiples of 7 are 7, 14, 21, 28, and so on. As far as 10 is concerned, you can get 1 times 10 as 10. You can also get 10 by the combination of 2 and 5. So these are the factors for 10. And the multiples will be 10, 20, 30, and so on. So what you notice here is that multiple is equal to the number itself or is greater than the number. As far as the factors are concerned, they are always less than or equal to the number. Well, this sign is denoting numbers itself. Do you see that? So factors are smaller than or equal to the number itself, and multiples are always greater than or equal to the number. So a better way definitely is to include the sign with greater than, like this. So that is the correct sign. So that is how we could actually understand what are factors. Now, the question for you is, how many factors are there for numbers like 5, 11, 13, and 17? So try to answer this particular question and then give their special name. Right? So that is a hint for you. Let's move on and take the next question. So as we move along, we'll actually understand the concept with the help of questions. Now in this particular slide, we will now understand how to write 24 as product of two or more numbers and how many combinations did we get. So these are the two questions to answer. So I've already shown you something here which says you could get 24 as a product of two numbers. So 24 as a product. So when we say product, they become the factors. So the two numbers which we are shown here are connected, and we kind of call this as a rainbow, connecting the two numbers. So we can write 24 as a product of two numbers in many different ways. We can say 1 times 24, this is one combination. We can say 2 times 12. We can say 3 times 8, or we can say 4 times 6. So these are all the combinations which can give you 24. But remember, we could also have more combinations, and that is, we could also say 1 time, you can take 6 as 1 time, 2 time, 3 time, so that is 6. And 6 times 4, you could also have a combination like this. So we could have combinations which could be kind of like this, right? So We have combinations which is like 4 times 6. The same combination can also be written as product of 1, 2, 3, and 4. So we could have many combinations. So the question here is, how many combinations did you get? So if you go with this kind of addition, there will be many combinations which we could use to get 24. Perfect. So there is a shortcut way to figure this out. We can find how many factors are there. So we say number of factors are 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 factors in all. Now, in these 8 factors, we can use one of them, we could use two of them, we could use three of them. So likewise, we could use different combinations to get the number. So there are total 8 factors, number of factors are 8, and as far as number of combinations are concerned, at present, we will say many, right? Now, how many, we will answer a bit later, right? We have to really count these kind of combinations. So how many, we will answer later. Okay, let's look into the second question, and that is, write 24 as a product of only prime numbers. Now that is critical. When we have to write 24 as a product of only prime numbers, how do we write that? So that is particularly called prime factorization. This is what we call prime factorization. Correct? So that is called prime factorization. How could we do it? Well, I will show you one way of doing it just now, and which is, let us say we are saying 4 times 6. Now 4 can be written as 2 times 2, and 6 can be written as 2 times 3. So we have written 24 as equal to 2 times 2 times 2 times 3. And in this particular case, we have only prime numbers. And this is what we call prime factorization. Is that clear to you? Now, how many of these are there? It is unique. It is the only way of writing. Correct? So, here in this prime factorization, what do we have? We have 3 2's, that is 2 to the power of 3, times we have only 1 3. So, we have these many numbers are involved. And from here, we can actually answer our previous question, which is number of combinations of these numbers. Well, we have 2's. We may or may not use the 2. We may just write 3 as one of our factors, correct? And as far as 3 is concerned, we may use it or we may not use it. So, for 3 2's, we have 4 combinations. And for 3, we have 2 combinations. And total, we have 8 combinations. So 8 is our answer. So total combinations are 8. So here is a strategy, and we actually got our answer, number of factors. We counted the number of factors as 8 earlier, and these are 1, 2, 3, 4, 6, 8, 12, and 24. In all, we have 8 factors of 24. And now, from the prime factors, we had a formula to get the number of factors. Do you see how important it is? Even without writing the factors, we have found the answer. So if you do prime factorization, you could also answer the question, how many factors are there? Perfect. So that is a key. Now, here are a few definitions for you. Prime numbers. So prime numbers have exactly 2 factors, which is itself and number 1. As you saw some prime numbers earlier, you can list many here. Numbers like 2, 3, 5, 7, 11, and so on, right? Now these are all prime numbers. When we talk about composite numbers, they have more than two factors. For example, 4, 6, 8, and so on are composite numbers. And now the question for you is number 1 a prime number? So I'd like you to answer this particular question, which is number 1 a prime number? You can always write this answer in the comments. Let's take up the next question now, which is, these are the questions for us, which is write 42 as product of only prime numbers or find prime factorization of 42. What are prime factors of 42? This is the second question to be answered. How do we write 42 as product of only prime numbers? This is what we will learn here. So here is a technique. We have 42, right? So we could write 42 as product of two numbers, 6 times 7. 6 can be written as 2 times 3, and then we have 7. So we have written 42 as product of only prime numbers. Do you see that? This process is called prime factorization. So here is what we are saying what prime factorization is. Prime factorization is to write number as product of only prime numbers. So we wrote 42 as only product of 2, 3 and 7, which are all prime numbers. Perfect. You get an idea? Let's take another number. For example, if I have a number 36, 36 could be written as 6 times 6. You can write 6 as 2 times 3 and this 6 also as 2 times 3. So that is also 36. So 36 now is written as a product of only prime numbers. Since there are two 2's, I could write this as 2 square times, or you can do multiplication sign, 3 square. That is the way in which we are writing in the form of powers. So we have used this time powers to write factors. Correct? Prime factors in this particular case. So that is another way of writing the prime factorization. Now with that, let's move forward. So we basically learned a couple of methods, right? At least one of them. Now here, we'll focus on prime factorization and see how can we get the prime factorization done. Prime factorization means to write a number as a product of prime numbers. Okay, so there are three methods which we'll discuss. Method number 1 is to continue to factor until all factors are prime. This is what we just now did. And method number 2 is to divide by a prime number. And method number 3 is combination of the above two. So we'll explore this in this particular example. Find prime factorization of 48 in different ways. So in three different ways we'll see. Then the second part of this question here is use powers to write prime factorization. And third, which is the better method? Explain. So we have three different ways. We'll figure this out. So let's use method 1 first. So I'm saying method 1, which is continue to factor until all factors are prime. And the number of our interest is 48. We could write 48 as 6 times 8. And 6 can be written as 2 times 3. 8 can be written as 2 times 4. Now 4 can be further written as product of 2's, right? 4 can be written as 2 times 2. Did you see how we wrote? So 4 we wrote as 2 times 2. Perfect. Earlier, 6 we wrote as 2 times 3. So we got prime factorization done. So that is how we are going to write. And in power form, we have how many 2's here? Well, we have 1, 2, 3, 4, 5 2's. We missed a 3 in between. I mean, this was 3, not 2. Okay, 2 times 3, right? So let me correct this. So we get 1, 2, 3, 4 2's. So I could write this as 2 to the power of 4 times 3. So that becomes our answer. Is that clear to you? This is using the first method, which is continue to factor until all factors are prime. So we kept on factoring until all were prime. This is one way of doing it. Okay, now let's figure out another way, which we'll call method 2. So the method 2 is basically to divide by prime number. So we have a number and we are going to divide this by prime number. We have a number 48. So you could divide by 2, for example. So you get number 24. Again by 2, we get the number 12. Again by 2, we get 6. This time by 2, you get 3. So you get all the prime numbers. So again, we get the same answer. We have 1, 2, 3, 4, and 1. So the answer remains the same. So this is equal to, once again, 2 to the power of 4 times 3. Is that clear to you? So we have exactly the same answer using the second method. Now let's look into the third method of combination of these two. The third method here is we'll begin with the number 48 and we'll branch off as we did earlier in this method. We could write 6 times 8 and then we can branch off and we can write 2 times 3 and this as what? 4 times 2 and this as 2 times 2. So it is kind of division but shown in a different way. And again, the end points are the terms which are prime numbers. And so the process is complete for us. And we can now write 48 as product of 2 times 2 times 2 times 1, 2, 3, 4 twos and 1, 3. And we get our result. So we get 48 as product of these. So you have seen 3 different ways of doing it, and you have also seen 3 different ways of writing it. So you note this is kind of important. 3 ways to do and 3 ways to write. Prime factorization. Is that clear? So first way is write as powers, as I've shown here with the multiplication sign, with the dot sign, and you can also write multiplication and dot either way, but put them all together as we have shown in the last case. This is called the power form. Correct? That is a shorter way of writing it. Now, which one is the best method? Well, all look equally good. But now we have an example here, and this example is find prime factorization of a number which is 3528. Oh, 3528. Use powers to write the prime factorization. Which method did you apply? Now, which method should we use to find the factors for 3528? Now, 3528 better ways this division, right? Better ways this division. Now, we can divide by some number. Uh, let's begin with 2, for example. So 2 will give us 2 times 1, 2 times 7 is 14, 12 is 6, and 4. Since it is an even number like this, last two numbers can be divided by 4. So we could also divide it by 4, right? So I could divide it by 4 also if I want to. So 4 times 4 is 16. We get 16 again, and 441. So we kind of saved a step. Do you see that? And now at this stage, we could divide 4 by 2 into 2, and 441. How can we divide this? 4 plus 4 is 8, 8 plus 1 is 9, so I could divide it by 9, right? So 9 times 5 is 45, so I could do 4, which will be 36, and we have 81, 9 times 9, and 49 can be written as 7 times 7. Did you see this part? Have a good look at it. It gives us more flexibility, shorter space, and definitely this is a far better method, especially when we are talking about big numbers like 3, 5, 2, 8 or something like this. So for smaller numbers also, it makes sense to write prime factorization to follow this process and then write the prime factors. Prime factors for us are the numbers which remain, which could not be factored. So those are definitely the prime numbers. 9, we forgot to write as 3 times 3. So let me just complete this as 3 times 3 to get our list. So you have to be slightly more careful. Okay, so we have our set of numbers. Let me write them. So we have 2 times 2, 2. So there are 3 2's. And there are 2 3's. And there are 2 7's. So that becomes the prime factorization, which you would also write as 2 to the power of 3, 3 to the power of 2, and 7 squared. Perfect. So that is how we will actually write it using powers for prime factorization. Correct? So which method is there? This is the method which we say a combination of division, and we kind of approach this as a tree approach, right? So tree method. It could be said as divide by prime numbers until you get all prime numbers. Correct? So that could be said like this, which basically matches with our method number 1, where we are giving it a combination since we have a flexibility. See, what is the flexibility? Flexibility is you could also divide by numbers which are not prime. So we kind of divide it by numbers which are not prime. So that is a shortcut. Do you see the difference between the two? So that really helps to get a faster answer. So that is the difference. Now we'll use this method, and so let's take a few more examples. Question here is relate factors with numbers. A number has 2, 3, 5 as prime factors. Which is the least possible number? Now, very important question here is which is the least possible number which will have 2, 3, and 5 as prime factors. So by multiplication we can get. So the number n will be 2 times 3 times 5, which is 30. So the answer is 30 is the least possible number. Is that clear? With 2, 3, and 5 as factors. Okay, as prime factors I should write. Is that okay? As prime factors. Now, part B here is write 2 more numbers which will have above factors. So other numbers we could write what? Well, 30, we could multiply by 2 and write 60. We can multiply 30 by 3, for example, and we can write 90. So these will be other numbers. Right? However, we see that 30 is least. And therefore, it is given a very special name, and that is called LCM. So least common multiple is 30, which you get by multiplying all the common prime factors. Correct? Now, next question here is prime factorization application. Write each number as a product of prime factors. So this is for practice. So take this as a practice exercise. Correct? Let me do one of them for you. Let's say 150. So you can go about like 15 times 10. Did we divide by a prime number? No. Any numbers you could choose. And 15 is 5 times 3. 10 is 2 times 5. And therefore, I could write 150 as equal to 2 times 3 times 5 square. And that becomes my answer. So likewise, I would like you to do the rest. The other way we found to get the factors was rainbow. We did it earlier. The question here is find all factors of 18 and 24, identify common factors, and find the greatest common factor. So in this case, we're trying to get the concept of common factors and the greatest common factors. Let's try to do this. So we'll begin with the number 18. 18 has factors 1. I'm writing far away. 1 times 18. 2 times 9 is also divisible by 3. 3 times 6 is 18. And that is all. How about 24? For 24, let's write down here. 24 is 1 times 24. 2 times 12. 3 times 8. 4 times 6. These are all the factors of 24. So we have done the first part, which is the rainbow part, to find all the factors. Now, why is it called rainbow? Since if you kind of connect them, right, so you can actually form a rainbow. I mean, I'm not connecting it the right way, but anyway, you know, um, this has to go to 9, right? So it forms a kind of rainbow, and that is how it gets named. Now, second question for us is identify common factors. So let's write down what are the common factors. So well, these are common factors which I'm shading. Many common factors are shaded, all of them, 4 common factors. Correct? Find the greatest common factor. So we have a term here which says greatest common factor, and clearly the greatest common factor is 6. So we get this number as 6. Do you see that? So using these factors, we found the greatest common factor. However, we have to write all the factors to get the greatest common factors. We'll learn another technique of finding lowest and greatest. Rather, lowest is always 1, but the greatest common factor, let's look into another technique. So this time, we'll do prime factorization approach for LCM and GCF. GCF is the greatest common factor, and LCM is the least common multiple. So again, we have a same question. However, we'll have a different method. It says find all factors of 36 and 48, first part. Identify common factors. Find greatest common factor. So how are we going to do it? Well, we'll have a different approach. We are saying prime factorization approach. So we will actually find all prime factors this time, not the actual factors. Okay. So let's take up the example for 36. 36 could be written as 6 times 6, and that could be written as 2 times 3, 2 times 3. So we can write 36 as equal to 2 times 2 times 3 times 3. Now, let's take the other number, which is for us 48. So 48 can be written as 6 times 8. 6 is 2 times 3, and 8 is 2 times 2 times 2. So we get 48. We did it earlier, right? So we have 1, 2, 3, 4 twos, 1, 2, 3, 4 twos, and 1, 3. Now we have to identify the common factors. So the common factors identified are, let's write down. So common factors are, we'll write common factors. Let's shade them. So we have common factors of 2's and 1 3's. So these are the common factors. Now it says find the greatest common factor. How do you find the greatest common factor? Well, clearly the greatest common factor is product of these 3's. So 2 times 3, which is 12. So 12 becomes the greatest common factor of 36 and 48. Do you see how easy it is? With prime factorization, we do not have to list all the factors. Correct? Now, we got our answer. How do we check this answer? We are saying that this is the greatest common factor. That means it can divide evenly. So let's check. So we could do 36 divided by 12. We get a number 3. And we can have 48 divided by 12. We get a number 4. So it evenly divides. And that is the key. So common factor will evenly divide all the numbers, and that is how you can actually check, right? So we have a definition here. Lowest common multiple, LCM, is the product of all common factors and the remaining factor. So that is how we can find LCM. Now, let us see how to find LCM also in this particular case, which is not mentioned here. Find the greatest common factor was mentioned, but let's extend this, right? So we'll extend and see how to find LCM. So it says once again, LCM is product of all common factors, which is GCF, and the remaining factors. So okay, so the remaining factors are 3 for 36, so we'll multiply by 3. And then we have these 2's, so 2 times 2. So basically we get 12 times 3 times 2 times 2. That becomes the lowest common multiple. So which is how much? So we have 12 times 3 is 36, twice 36 is 72, and twice 72 is 144. So 144 becomes the lowest common multiple for 36 and 48. Correct? Okay, so that is how we could get with prime factors. So let's extend our cases now, and now we are getting into very difficult kind of questions based on prime factorization. This video will actually give you complete review of the whole unit. Okay, so we're looking into the application part of prime factorization. Question is, find the least number with factors 6, 8, and 15. So we have to find the least number n which has these three factors, which are 6, 8, and 15 as factors. That is the question. How do we get that? Okay, so what we will do here is write these as their prime factors, and then I hope we'll get our answer. 6 could be written as 2 times 3. 8 could be written as we saw 2 times 2 times 2, and 15 can be written as 3 times 5. So we have to have all these combined numbers in our number so that 6, 8, and 15 can also become a factor. So let us see how many 2's we need. Maximum number of 2's which we need will be 3. So we are looking for maximum number. Each prime number. So as far as 2's are concerned, maximum number of 2's are in 8. So we will take these 3 2's, right? So we have one number which is 2 times 2 times 2. Now let's look for 3's. Well, 3 is only 1 and 1, so one of them has to be taken. And then we're left with 5, which is only 1. So that combination should give us the number n. That is the way of finding the least number. We're looking for the least number. Is that clear to you? That least number is right there before us. Let's multiply and get our answer. So we get, it's easy to combine this first. 2 times 5 is 10, correct? 3, 30, 60, 120. So we get 120 as our answer. So the least number here is 120. You can see that 120 has all the three factors. which is 6, 8, and 15. You can divide 120 by 6, 8, and 15. You will get natural numbers. And that is how you could confirm. So I hope you have understood the process of getting the least number with the given factors. Perfect. Next example. Concept of prime factorization. It says find the number for given prime factors. So we are now given the prime factors, right? So I should actually write prime factorization. So the number basically is the product of all the prime numbers. So it is 2 times 2 times 2, 3 times 3 times 5, right? So which is, this number is 8, this number is 9, this is 5. So when you multiply, it's better to multiply this first. It is 40 times, let me write 9, and we get the number as 360 as our answer. Is that clear to you? Correct? So I hope you have understood the concepts. Now, here is another important question which says find number n for the prime factors, and now here is a twist to it, which is how many even factors will n have? So first case is to find n, which we did just now. N is equal to 2 times 2 times 2 times 3 times 3 times 5, and we found that this is 3 times 5 is 15, 15 times 3 is 45, twice is 90, twice is 90, 180, and then 360. So as in the previous case, we got the same answer, n equals to 360 as expected, since we have the same set of numbers. However, there is a twist to it. The question now to do is how many even factors will n have? So it is a question of how many factors. So first is, let's figure out how many factors. How do we figure this out? Well, we have 3 2's, we have 2 3's, and we have a 5. So that should give us a combination of 4 2's. That is, you may select a 2, you may select 2 2's, 1 2, 3 2, or no 2. So those are the 4 combinations. So we are now looking for combinations. So with 2's, we have 0 2, we have 1 2, we have 2 2, or we have 3 2's. So if I have 2 to the power of 3, so these are the 4 combinations. Do you see that part? As far as 3 is concerned, we have 2 3's, so we have 3 combinations. 5, we have 1 5. We may choose it, we may not choose it. 2 combinations. Multiplying these, 6 times 4 is 24. So we have 24 combinations, and therefore we have 24 factors. Is that correct? That is how we are going to find it. One of these combinations is not to select any of these. In that case, 1 is the number, and the second one is select them all, and that is the number itself. Okay. Now the question is, how many even? How do you figure this out? Well, let's find how many odd. So odd numbers will not have 2, will have only 3, 3, and 5, which is 3 squared times 5. Number of combinations, let's find odd combinations. So we have 3 of 3's and 2 of that, which is 6. So therefore we get our answer. Even combinations are difference of the two. So we have 24 minus 6, which is the answer. Is that clear? Which is 18. So we have our answer. 18 is the even combinations. And how did we figure this out? We found the total number of combinations is 24, out of which 6 are odd, rest are even. Even combinations will have at least 1 2, but it should have a 2, right? That is how we figure this out. This is extremely important question. Normally, it will be a bonus question for you. Now, next question here is, Again on prime factorization application. This time, prime factors of two numbers is given below. These are prime factors. Find the number a and b. You have to find all common factors of a and b. Find greatest common factor and find the first three common multiples of a and b. That is the question for you. How do we do this? Okay. First part is clear. What is a for us? If I multiply, I get my number. So a is basically equals to 2 times 2, 4, 4 times 9, which is 36. As far as b is concerned, we have 30. 2 times 3, 6 times 5, 30. So a and b is known to us. So we know a is equal to 36 and b is equal to 30. So we have found these two numbers. Now the question is, find all common factors of a and b. So let's have common factors now. So the common factors are, so let's circle or highlight the common factors. So we have 2 as a common factor. We have 3 as a common factors. So 2 times 3, these are the common factors. So we could have common factors as 2 or 3, right? Is that all? Well, we also get 6. When you multiply 2 and 3, you get 6. So the common factors actually are 2, 3, and 6. You get an idea. So that is a trick. So it is very important to understand that you get the factors of factors by multiplying them. Okay. So find all common factors. All will include this. What else? Well, we are saying find all common factors. We are not saying prime. Find all common factors of A and B. So we have to also include the number 1. 1 is always a common factor. So we have 4 common factors. We are not saying prime factors. Do you understand? So we have 4 common factors and these 4 numbers are 1, 2, 3 and 6. Now the question is find the greatest common factor. So out of these, the greatest common factor is indeed 6. Correct? So we got this answer also, those two done. Now the question is find the first three multiples this time of A and B. So multiples are bigger numbers. Correct? How do we get the multiples? So let's start with the LCM, the least multiple, which will be greatest common factor times the numbers which were not used. So the numbers which were not used were number 2, 3 from here. So we'll multiply by 2 and 3 and the number 5 from there. So 6 times these numbers. Greatest common factor is 6. So put 6 here and multiply. So 6 times 10 is 60, 180 is your answer. So 180 is the LCM, right? So that is your first of the three numbers. How do we get the others? Others you can get by multiplying 120 by 1, 2, 3, 4 and so on. So if I multiply by 2, I get 360. And then the next will be multiply this by 3. So we get 0. 3 times 8 is 24 and we get 540. So these are your first three prime factors. Does make sense to you? And that is how you're going to find it. It's a very tricky, good example to understand. With that, we come to an end almost. And here are 8 questions for you to do. These are practice questions. I like you to pause the video, answer all these questions. You need to list factors of 72, find prime factorization of the number 102, use powers to write the answer. Is 1 a prime number? Can even numbers be prime numbers? Can product of two prime numbers be a prime number? How many prime numbers are less than 100? List them. Prime factors of number n are 2, 3, 3, 3, 5, 5. find the number, right? How many factors will n have? How many factors of n will be odd numbers? And find the LCM and GCF of 48 and 30. So these are your questions, which I like you to pause the video and answer them. So few interesting one. Is 1 a prime number? What do you say? Yes or no? The answer is no, right? So let me write down the answer here. It is no. Why? Because 1 has only one factor. So in prime factorization, we never write 1. Can even number be a prime number? Yes, 2 is the smallest prime number, right? Smallest prime number. Perfect. These are very important things to understand. Rest, you could go through and see the examples to answer. So I hope with that, things are absolutely clear. Here is a very interesting question, which is extended application. Some of you can try this. So in this application, we are saying prime factorization of a number is 2 cube times 3 square times 5 square times 7. Find the number. That is simple, just multiply them. How many factors will this have? So the hint here is we have 3 2's. We could take 4 of them, combinations. 2 3's, we could take 3 combinations. No 3, 1 3, 2 3. That is our 3 combinations. 2 5's, 3 combinations. No 5, 1 5, 2 5. And 7, only 1. So we can have 2 combination. We may take it, we may not take it. When you multiply this, you get your answer. Correct? Now, very interesting part here is perfect, abundant, and deficient factors. Now, this is only for those students who want to learn a bit more. It says, write factors and add all factors except the number itself. Compare this sum with the numbers to classify as a perfect, abundant, or deficient factor. Which of the given numbers are perfect numbers? 6, 13, 18, and 28. Let me explain you what I'm trying to say. 6, the factors of 6 are 1, 2, 3, and 6, right? Now, if I add 1, 2, and 3, what do I get? If I add 1, 2, and 3, I get 6. They are equal. Do you see that part? So accept the number itself, right? So write factors, we did one, we wrote all the factors and add all factors except the number itself. So except 6 we added. So we added these. And what do we get? 6, number itself. Then becomes a perfect factor. So this 6 is a perfect factor. So likewise, you can check, do we have any other perfect factor here in this list? And then if you have less factors like 13, now 13 has only 2 factors, 1 and 13, correct? So you don't have to add 13, 1 is smaller. So this will be classified as deficient. If the sum is more, then in that case it will be abundant. Is that okay? So these are the terms which are sometimes used. So with that, we come to an end of our unit on prime factorization. We have learned so many concepts. I hope you will appreciate it. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thank you and all the best.